You're listening to World Oil Deep Dive, conversations with energy industry leaders and engineers about the market trends and technologies shaping the oil and gas industry. Now, here's this week's episode.
Welcome to another version of the World Oil Deep Dive podcast. My name is Kurt Abraham. I'm editor-in-chief, and I am your moderator. In this session, we're speaking with Nick Rakich, Sales Director at Welltec. Reliable annular insulation is a cornerstone of well integrity, ensuring safe and efficient operations throughout the life of the well. However, achieving this reliability is often complicated by persistent challenges, such as sustained casing pressure, difficulty in reaching the top of the cement, isolating complex or heterogeneous formations. These issues can lead to costly remedial intervention, increased operational risk, and compromised well performance. So Welltec's metal expandable packer technology offers a proactive solution to this situation. So, Nick, welcome. Tell us, what is annular isolation? Why is it so critical to well integrity?
Thanks, Kurt. Great to be with you guys. I guess if we start with that topic there and the foundations, annular isolation really comes down to the sealing of the space between casing and formation, or casing and casing. And this is to prevent fluid migration or gas migration through that annulus. It also ensures well integrity, which is quite important, in not just during the drilling phase, but for the life of the well, and ensures safe and environmental protection while operating the well. Without it, in fact, fluids could migrate between zones or to surface, causing contamination or, in worst case, blowouts.
So what would you say are some of the common challenges that the operators face in achieving this reliable annular isolation?
Yeah, certainly a number of challenges. Maybe if I consider U.S. unconventional markets, for example, achieving cement top is very important with respect to regulatory compliance. And considering complex well geometries and longer wells, this can become more and more challenging. Additionally, isolating high pressure and depleted zones can be very difficult as they require different cement slurries traditionally, but also can allow for cement contaminations during the curing phase. If we consider geology, cementing or isolating, I should say, saltwater disposal zones, for example, can be very challenging considering the overpressured nature of those zones. And some examples could be the Delaware Mountain Group in the Delaware Basin, the San Andres Formation in Midland Basin, and maybe even the Dakota sands there in the Bakken. Additionally, when you have those challenges or in cementing or isolation, it could result in sustained casing pressure, as you mentioned in the introduction there, also known as Braden head pressure, and that will lead to the regulatory noncompliance. And in general, all these different types of challenges require remedial work, which will increase non-productive time on the well and costs of the well.
All righty. So, in your opinion, why do these challenges often lead to costly remedial situations, and what risks do they pose to well performance?
Well, when you have these challenges, you have to remediate them, and quite often that's done by cement squeeze operations or top-down cementing, also known as Braden head cementing, which can be vary in terms of results and reliability long term. In fact, you could even end up with sidetracked wells because of challenges in annular isolation. Some operators have turned to alternative solutions, considering, for example, two-stage cementing operations, but that also always doesn't guarantee that you're going to maintain long-term annular isolation. Therefore, it may be a short-term fix, but it's not a long-term solution in reality. Again, increasing rig time, you could have water production. Another result of that could be flaring or venting of gas if it shows up at surface. And in the end, you end up with compromised well integrity and potential financial losses, environmental hazards.
All right. So maybe you can comment on what makes Welltec's metal expandable packer technology a little bit different from traditional isolation methods.
Well, Welltec's really a tech, solution technology company when I think about what we do. It's really in our DNA to be innovators. We've been doing this for 30 years, developing technologies for the energy industry through collaboration with operators in recognizing challenges and finding solutions to those challenges. And about 2009, we began development on our metal expandable packer technology and really introduced it with the first deployment happening in 2012 in the North Sea. Since then, we've developed solutions for different markets, different fields, different challenges within those fields, building on our innovative approach. The metal expandable packer technology really differentiated itself through the design, including the fact that it's a metal expandable sealing mechanism. So if you think of it as a metal expandable balloon that plastically deforms and creates a life of well barrier or what life of well annular isolation mechanism, conforming to irregular well bores or even casing IDs. Another big differentiator there is it's not affected by temperature variation or pressure variations through the life cycle of the well. So for example, when a well is fracked, it's going to see many, many cycles of pressure, which could debond cement, which is conventionally used, or even create microannulus. The metal expandable packer is completely unaffected by those scenarios, and overall will ensure that we can provide life of well integrity to operators that's not susceptible to that debonding or microannulus as experienced by cement.
Understood. Not to take a pun off of our webcast title, but maybe you could do a little bit more of a deep dive into the engineering that's behind the technology and how that achieves this robust isolation.
Yeah, so going back to the DNA of Welltec and really being a company that develops solutions, everything is in-house. So the design aspect, the engineering aspect, and the manufacturing aspect of the metal expandable packer solutions are done at Welltec. So we have a lot of control over the engineering of the packer. The packer's expansion itself is driven by hydraulics. There's no moving parts. It's a very simple design, but very efficient. There's a redundant sealing mechanism. So instead of having a single seal, for example, the packer itself has multiple seals, which enables redundancy, but it's almost like having multiple packers in a row on a single packer. They're completely independent, all those seals, so if one were to be compromised over the life of the well, the next seal is there to catch the differential pressure and overall prevent any leak by. Additionally, it's qualified to the most stringent ISO and API standards for gas-tight sealing, and that's intentional such that we can ensure that it is a life of well solution. We have high burst and collapse ratings that go beyond conventional solutions. And going back to the simplicity of the design, when you simplify a design, you minimize the failure points that could present themselves over the life of the solution.
Sure. So then how does the technology help the operators design wells that prevent these issues before they can occur?
Yeah, so in general, the approach has always been remediation. So it's a reactive approach versus that preventative approach. And by installing these metal expandable packers during the well construction phase of a well's life, we ensure that we catch any problems from the beginning without the need for remediation. So eliminating reliance on cement alone, for example. Again, it can be used in combination with cement or standalone. But in both cases, we're not reliant on the cement. Operators in general will also reduce risk of sustained casing pressure or braiding head pressure in zone communication. And in general, it'll enable them to simplify well architecture for complex formations, maybe reducing the need for an additional casing string or, as I mentioned, two-stage cementing operations, which really brings the time to construct the well down whilst improving annular isolation efficacy.
So back out in the field, what would you say are the types of wells or environments that would benefit most from these metal expandable packers?
Well, wells across many different basins, I'd say. We know globally an average number that's thrown around is 15% of wells suffering sustained casing pressure in the annular space. And considering that, we looked at the number of wells simply drilled in the unconventional basins, which is a majority of the wells drilled. So certainly they can experience the challenges mentioned previously regarding fracking and multiple pressure cycles resulting in cement failure. Uh, other wells, for example, in deep water environments, high pressure, high temperature wells can also benefit, considering limited solutions available for annular isolation outside of cement in those applications. Wells in general that require zonal isolation, stacked reservoirs, differentially pressured zones where cement placement is challenged can also benefit. And finally, I'd say complex formations with irregular borehole geometries where cement becomes quite challenged, particularly when we look at very narrow annular spaces. Cementing can be very difficult in those circumstances, and that's another example of where these metal expandable packers can be provided and provide the most benefit.
So in terms of the technology eliminating remedial work, maybe you could share an example or case study story that would illustrate this.
Yeah, we have many examples all over the world. I'm here in Houston, so maybe I'll kick off with some U.S. unconventional examples. Currently, Permian operators are utilizing this technology in cases where they've experienced frac hits to surface. So, for example, they would be fracking a well, and in an offset well, that frac pressure would become observed and show up at surface. And there's a need to remediate then, so you have to stop the frac, you have to shut in the other well, so you lose production, you lose frac time, and then they traditionally conduct a braided head cement job or a top-down cement job. And we've been utilizing these packers to prevent that by placing them as part of the production casing string and isolating the annulus between the production casing and the intermediate casing, and overall preventing those frac hits from showing up to surface. Another example could be in the DJ Basin, where braided head pressure really is a very challenging obstacle to well compliance. They've introduced regulation there, in fact, requiring the mitigation or prevention of braided head pressure. And quite often that's quite difficult when you consider it's a two-string design normally there with a surface casing and a production casing. So there's little room for error. If there is a need to remediate, you're remediating your production casing, which you're going to frac through in the future, and can become quite difficult regulatory compliance situations. Other examples could be deep water clients with highly depleted zones, losing their cement jobs to those depleted zones. And really then by utilizing this technology, they've been able to eliminate the need for cement squeezes and two-stage cementing operations, delivering long-term well integrity without the need for that remedial work.
All right. Well, I'm sure there's somebody out there in the audience that's going to want to know, how does this installation process compare to alternative solutions? Does it simplify the operations? Does it reduce rig time?
Yes, in fact, it's almost seamless the way it's integrated into existing well construction or cementing programs. The metal expandable packers are run as part of casing string, and once the cement job is completed, a simple pressure cycle expands the packer and isolates the annulus. So it's really a 15 to 25 minute pressure cycle on a well to expand and isolate the annulus after cementing there. Another big comparison when you look at alternative solutions is there's no additional tools required for installing these packers. There's no, as I mentioned earlier, moving parts, so little room for failure there. and it really reduces time and operational complexity through its simplicity and when it's compared to alternatives. So really, when I look at it, I'd say there's much lower risk during installation compared to alternative solutions.
All right. So here's another performance-oriented question that people want to know, and that is, what are the measurable benefits that operators are realizing from adopting this solution?
There's many. I'd say, addressing the life of well challenge. So these annular isolation challenges, whether it be sustained casing pressure, braided head pressure, cement losses, or water production, for example, these can all occur either during drilling, completions, production, really at any stage during the life of the well. Um, in terms of measurable benefits, we see a significant reduction or even elimination in remedial operations, which saves time and saves costs and saves well production. The other benefit is improved well integrity. So, for example, we had an operator in the U.S. unconventional basins that was experiencing braided head pressure on 30% of their wells. And by including this metal expandable packer into their well construction procedure, they managed to reduce that from 30% right down to almost zero. So significant benefit there. When you look at costs, when you look at time savings there, it's really huge for the clients. Otherwise, if we look at taking a preventative approach versus a remedial approach, so a small investment earlier in the well construction phase is going to save the operator a lot of money long term with respect to elimination of remedial work. So I guess enhancing the long-term performance and reliability of the wells is possible just through the use of this solution.
Well, speaking of that, we're probably not enough years down the road yet, but in your estimation, how does this technology contribute to the long-term well performance and the sustainability goals?
Well, as I've mentioned, we're providing permanent sealing, life of well reliability. We have metal expandable packers that have been in the well since 2012, for example, with a track record of performance. Certainly, we reduce the environmental risk by preventing fluid migration to the operator. We also reduce exposure to regulatory and legal consequences. I previously mentioned Colorado as an example, where Senate Bill 181 showed up in January 2021 and really made it forefront, annular isolation, a forefront of the operator's agenda when it comes to sustainability and performance. So in general, if we're looking at reducing liability, reducing risk during abandonment, and reducing costs long term, I think these are really well performance sustainability goals that operators have to achieve without even mentioning ESG goals through mitigating emissions from flaring and venting, for example, if there is gas at surface.
All right. So, Nick, what do you think the future looks like for annular isolation technology? Are there innovations or trends that operators ought to be looking out for?
There's lots of technology on the forefront right now. I think what we're seeing is a more proactive approach to mitigating or eliminating the challenge of annular isolation through incorporation of solutions like metal expandable packers, which really will minimize the need for intervention and workovers. This growing demand for technologies, I think, also enables the reduction of the carbon footprint by, as I previously mentioned, eliminating the need to vent or flare. And also, I think when it comes to Welltec's vision, continuing our innovation, such as the metal expandable packer technology, and building on that platform to more challenging wells with respect to differential pressures, higher temperatures, and overall more complexity in well design is where we see things going and where we see the need for technology. So we're going to continue to develop our metal expandable packer technology and really try to future-proof our solutions for the increase in complexity in wells.
All right. Well, thank you so much, Nick. Well, folks, we're out of time for this episode. Our thanks to Welltec's Nick Rakich for his insightful comments. And as always, thanks to all of you out there for listening. Good day.
Thanks for tuning in to our show. Please check out the show notes for the links we discussed in the podcast. We value your opinions, so if you have any questions or comments, kindly email them to us at deepdive@worldoil.com. Additionally, we'd appreciate it if you could rate us on your preferred podcast listening app. Lastly, don't forget to visit worldoil.com for the latest technical articles and news about the oil and gas industry.